Hello everyone. In this video, we are going to take some healthcare data based on patients' responses to questions from a particular clinic. These patients and their information has been scrubbed. The identities are impossible to know. We're going to look at the data and study two different outcomes. So we're going to have two files of the same data, but we have a validated response for both data sets. We are going to use a questionnaire that a registered nurse or PA uses when consulting with patients simultaneously or before the medical doctor would typically enter the room, or in other cases, the medical doctor themselves would utilize this survey. We're going to log into SAS in our normal fashion. I don't know if there's any Seinfeld fans out there, but that thought just maybe think of it in our normal fashion. Okay, and we are going to look at the Excel files first. Actually CSV files, but we'll use Excel. The reason for this is I want to make sure you understand what the data is before we begin. Okay. So what we have here is we have several variables. We have patients, which is more like an artificial key. It means something, not to you because this has been encrypted, but it's a way for us to talk later about how a regression problem is discussed in business or evaluated for merit. We got several variables here, and then we have doctor confirmed pneumonia. Okay, so we have, that's our outcome, that's our Y variable. And all the way over here, we have 51 total variables. How many rows of data do we have? We have 5,000 exactly. Now, one thing I want you to note in this pneumonia file, because it's going to be different when we look at the sinus infection file, is that I've already diced out all of the possible values, the categoricals, right? We've talked about this before. I've already put 1 if it's male, else 0, 1 if it's female, else 0, and then based on age information here. And then these are all, are you there? You know, are you in college? Are you reporting cramps today? Do you have stomach pain, nausea, vomiting, etc.? And then swollen tonsils, swollen lymph nodes and glands, and things like that. So some of this is reported by the PA or the RN, and it's not just self-reported by the patient when they come in the room here. So go ahead and open the other data set. So we have another data set here, and it's very similar. In fact, okay, we've got all the variables that are the same here, except are you sick with sinus infection? That is our Y variable. One thing you'll note here that's different from the previous file that I just showed you is gender is listed as M or F. In the previous file, I had already did that if statement for you. I'm going to show you once again how SAS can handle this. Okay, I'm intentionally leaving it male, female here. Okay. Remember, we have to upload before we can import. So we're going to choose the files here. You can select multiple at a time. Upload. This was a study that was done a couple of years ago, I think about 5 years ago. So here we have our data here, patient data pneumonia, patient data sinus infection. You know, I'm just gonna, so we got our two data sets. Now we're going to import them. And remember, we're going to import both of these. And the reason for that is so I don't have to do this again. 2 in 1 shot, economies of scale here. Now, if we aren't careful, we're going to overwrite our second file because both of them will be called import. So we want to put patient data pneumonia. Okay. Now, one thing that a couple of you have discovered is when you set that up, you don't hit the run button. So make sure you hit that run button. Now the next one, we're going to click on that one, right click, and we'll import data. And we're going to do the same thing here. Make sure you keep your naming conventions, otherwise that could be real headache for you. Sinus infection. Now, does it have to be the same name as your Excel file? No, it just so happens I'm comfortable with that. Okay, and hit the run. All right. Okay, so tasks, go into binary logistic regression. Okay, so it tries to remember what you did last time, so don't assume, oh, I see the word pneumonia there, then this is going to work. No, that was my old file when I was practicing up on this. So hit OK. Now, response variable, do you remember what that was? That was doctor confirmed pneumonia. Now, what I wanted to look at here is notice this A versus numbers. I didn't highlight this before, but I gather you figured it out. But categorical versus quantitative. In this case, binary, because we set it up already. But you know. Event of interest. Now, a couple of you missed this. So, event of interest. Now, remember, I'm in binary logistic regression. I'm not in linear, and I'm not in predictive regression models. A couple of you have gone that route and have clicked on some of these, looking for that binary stuff. So level of interest, I'm really interested in who has it. Okay. Ultimately, this doesn't really matter because the data we're going to get back is going to give us a score with all of the variables we already submitted. So, but level of interest to me is, I'm most interested in those that have pneumonia because then I can treat them. No different than if we were to do a model on customers at the store, trying to figure out, will they buy this? Here's some demographic or segmentation variables on the customer. Here's the price point. Is it on promotion? Yes or no? Was it in the flyer? Yes or no? You can imagine a lot of variables. I want to know if they're going to buy it. Now you could argue, well, I want to know if they're not going to buy it because I want to convert those non-buyers into buyers. Is it potato? Okay, so logistic function, classification variables. These are not classification variables. You could argue that patient data, because it's categorical, should be used in this, but no, that's just, as I said before, an artificial key. It's a way for us to keep it straight. Because you have to put this in context. We're studying patients, we're studying human beings, and we want to be able to bring a score back to identify whether our model was accurate. So no, we're not doing anything here. Now, when we look at the sinus infection file, yes, we're going to play with that a little bit. So nothing in classification. Now over here, again, note, now we have continuous, which is looking for quantitative variables. Note that patient isn't here. SAS is smart enough to recognize that. Okay, so hit OK. Now, you could hit run here, but what we're looking for, leave it as main effects. Nothing special for selection. What I want you to do is scroll over, and your window size might be a little different. Output. I want you to create a scored data set. Okay. And what that'll do is that'll create a file for us to export into our server files. It's very confusing, so you'll have to pay close attention to that. So hit run. It does not take long. So 2 levels. Okay, here's what we had. We had 2,500 no pneumonia, and then 2,500 that definitely had pneumonia. Our AIC, again, I always think about A1C. Intercept only is horrible. Intercept with the variables is 102. This is going to be important for us later because the other reason I'm sharing the sinus file, 2 files today, is because I want you to look at the differences. Because I want you to see, okay, is binary logistic regression, the way that we have it set up for pneumonia and sinus infection, which one predicts better? Which one has a lower AIC? Okay. Remember, lower the better. Okay, it's not like R squared where we want higher, values. Okay. So what this has found, and this is what I was talking about before, SAS will look at some variables and identify zeros because they're a combination of other variables. It's figured out that when you take female is the opposite of male minus or intercept minus male. Age of 50 is the opposite of these here. And then winter, which should say winter. So hooray if you spotted that error. I give you kudos. I had found it earlier. So when we look at the sinus infection file, you'll see that there's a winter variable instead of winter. But sometimes I like to leave those in there to teach you that real world experience. Many of you have taken business analytics, and some of you are taking it right now and just finished up that promotion assignment where there were definitely some errors in that assignment. So don't lose sight of that. I know we're talking data mining today, and we're talking logistic regression, and we're talking about studying multiple outcomes, but never lose sight, never, ever lose sight and take for granted that your variable names and your variable data is correct, okay? So like what I didn't talk about this, but I made sure there weren't any 2s or 3s in the data set. If I'm told that I'm doing binary logistic regression, there better only be 1s and 0s in my data set, other than, of course, categorical classification variables. So again, never lose sight of that. Never lose sight of that. That to me is more important than anything, because if you submit, there's this phrase called junk in and junk out, where if you put junk into SAS or R or Python or Excel or Tableau or SQL, you're going to get junk out. So these are all of your, sorry, I skipped it here. These are all of your coefficients to use in your model to predict, and you study it, as well when we do the sinus infection. Okay, so the output data. So it's output over here. We have to hit run, so don't forget to hit run. Actually, we've already done that, but don't worry about that. We'll just do it again, just for good measure, I guess. I would like feedback. That's one of the things I don't like about SAS is if you ask you to do multiple things, it doesn't really give you good feedback. Where did that go? Well, we have to be careful here because of what I said earlier. Logistic scores, that's going to be the same default name that SAS will give all of our work. So logistic scores here, this is it. I would rename that to logistic scores pneumonia. Okay, because again, we're gonna do this with the sinus infection. We'll be careful. Okay, so here's our data. We are going to right-click and we are going to export it to our files. Okay, so this is that stuff before. We're just going to export it to our files. We have to export before we can download when it comes to this. So just like before, we have to upload before we can import. Now we have to export from our library before we can download. A little tedious.